Good afternoon and welcome back to Dr. Logic awkwardly does logic in her bedroom. Let's do more predicate logic proofs, and in particular, let's do an example that involves the existential elimination rule, because that's the tricky one that I said I would give you more information about. Let's bring up our whiteboard, and hopefully I can write small enough that we will have space to do everything we want to do. I've got a lovely example for us to work through. It's got two premises. The first one is that for all x, either ax or bx implies cx. And the second one says that there is a y, ay, and dy. So here are our two assumptions. And our goal, what we would like to prove, is that there is something that is C. Now, before you get started, it's really useful to look at what your premises are saying and what your goal is saying, and then work from there. So this one says anything, if it's either A or B, then it's C. So every apple or banana is a fruit. You could think of it as saying something like that. And then this says there is something that is both A and D. But if there's something that's A, well, then it's going to be either A or B, and therefore it meets this universal condition in the first premise, so it's going to be C. So whatever thing is both A and D is going to be the thing that is C. So there you've got kind of a sense of why this is something that should work. Now, what we're trying to prove is an existential. So existential introduction says that if we can get to a point where I can have some formula followed by some constant, then I can swap out that constant for a variable and put an existential quantifier on the front. So we can kind of file this away in the back of our mind that this is going to be, if we can get something like this, this is a good sign. Up here, we've got our universal premise. And remember what I've said previously, anytime you have a universal, do universal elimination for all of the constants that you have in your proof. Well, guess what? We don't have any constants yet. And we have this persnickety existential statement that we need to eliminate. Let's start with it. The way to eliminate an existential is to start off with an assumption about what this object is named. So I am going to name it F because we aren't using F's elsewhere, and this will make saying it out loud easier. So I'm going to assume that there is something that is both A and D, and this thing is called F. Now, remember that we have provisos about where F can occur once we get to the point where we want to apply the existential elimination rule. I will get to those when it comes time to apply the rule. Let's just work with what we've got. It's a conjunction. What do you do with conjunctions? You always do conjunction elimination, because the simpler formula that you have, the easier. So conjunction elimination twice gets us AF and DF. Now we have a constant. Yay! Go back and do your universal elimination on line 1. So this one says, if you have something that is either A or B, then that particular thing is going to be C. So universal elimination on line 1 erases the quantifier, erases the variables, and replaces the variables, those gaps, with a constant. And now at this point, we're basically just doing propositional logic. So from line 4, if we have AF, we know that we also have AF or BF through disjunction introduction. It's line 3. Line 4. And then between lines 6 and 7, we have a conditional and the conditional's antecedent. So let's get the consequent on line 8 through conditional elimination, 6 and 7. And now look at that. Look, we have predicate C applied to a constant. So we have something that looks very much like our kind of interim goal that we were trying to remember. The fact that it says A rather than F doesn't really make a difference. You might at this point be like, aha, I have found the formula that I want. This is the thing that I should pull outside of my assumption at line 3 using existential elimination. But what were our provisos that we have to check for every time that we apply the rule? Whatever formula we want to pull out cannot have the constant that was in our assumption. So this is not yet in a point where we can pull it out, because our assumption that the object that was A and D was named F was pulled out of nowhere. It was arbitrary. So I don't want to be able to come out here and say, apart from that assumption, I know that F is C. No. All I know is that something is C, whether or not it happens to be F. So if I do my existential introduction on line 8, now all of a sudden I have a formula where the constant that I introduced at line 3 doesn't occur in any other assumption other than the one at line 3. And the formula that I want to pull out of this subproof doesn't use that constant. So I can conclude that there is something that is C. And this through existential elimination, citing line 2, and then the entire subproof. The point of this is that this bit that I did here, I could have used any constant and the proof would still work. So I could have chosen D, I could have chosen P, I could have chosen G, I could have chosen A. Whatever letter I happened to write down did not actually impinge on what I was able to prove in the end, because all I proved was this more generic statement that there's something that is C. I don't make any assumptions about what it is named. So there's your first example of a proof involving existential elimination. We will probably do a few more examples just because, proofs are fun. Why not? If I have to sit here and record videos, why not do fun predicate logic proofs? Besides, I've got a stack of notes here of examples that we can go through. So join me again next time. We'll do a couple more before we get tired of this topic. Take care. Cheers.